I'm Anil Kumar, and in this series of challenge questions for grade 11 and 12 students, here is a question on transformation. The function f of x has been reflected on the x-axis, vertically compressed by a factor of half, horizontally stretched by a factor of 2, translated 1 unit to left and 3 units up. The point P 1 is on this transformed function. Determine the original coordinates of this point on f of x. Read the problem carefully, pause the video, copy, and solve this question. Once you have solved, look into my suggestions. So let's begin with this transformed function f of x and understand what are the transformations. So it says the function of f of x has been reflected on x-axis. So the first one is reflected on x-axis. And then vertically compressed by a factor of half. So we have vertically compressed. Let me write by half. I'm not writing factor here. Horizontally stretched by a factor of 2. So horizontally stretched by factor of 2. Translated 1 unit left. So 1 unit left and 3 units up. 3 units up. So that is the transformation which is being performed on the function f of x. Now this kind of transformation, let's call this function transformed function as g of x, right? So g of x equation should be what? Reflected on x-axis means minus, vertically compressed by a factor of half, so it is half here, right? Horizontal things come inside the bracket, so let me write the function f, right? So this is the function. Inside that, horizontally stretched by a factor of 2, so it comes stretched by a factor of 2, that means 1 over 2, right? That is what it is. And bracket open, 1 unit left, so x plus 1, that means minus 1 will make it 0, 1 unit left. 3 units up means plus 3. So that becomes a function. So we have a function g of x, transformed function, whose equation should be minus half f of half x plus 1 plus 3. Now, the point P 1 is on this transformed function. So on g of x, we have a point 1. So we have point 1 on g of x. Determine the original point on f of x. So we want this point on f of x. So we are given the image. So that is the image, right? So we are given the image. We want to find original point. This is the question, right? I hope you understand what the question is. So we'll call this image as P, and the original point, let this be, let's say A. Okay, let's call this as A. Fine. So what should this point A be? I hope that is clear. This is the question for us. On the right side of this page, we will see how we can answer this kind of question using transformation of points from original to the image, right? Let's go through this transformation, and let us say the original point is x0, y0, right? So when you transform this point, what happens to x? So x is horizontal, right? So these are the things happening to x. Two things, horizontally stretched by a factor of 2, right? So what really happens is that the x point gets multiplied by 2, and 1 unit left means minus 1. So it is 2 times x0 minus 1. So this is what happens to the x values. As far as the y values are concerned, reflected on x-axis means minus, vertically compressed by half. So they get multiplied by negative half of the original y value, and then 3 units up means you add 3 to it, correct? So that is the kind of transformation which takes place. Now we are given a point on this function. So this is the transform function g of x, right? And this is on f of x. We need to find the original points, x0, y0, right? So how can we do it? Now what we know here is that g of x is 3, 1. So it is actually 3 and 1. That means this value of x is 3 and this value of y is 1. We can equate and find the original point. That is how it should be done. I hope you understand and appreciate the method. So 2x0 minus 1 equals to 3. So we can rearrange. So we have 2x subscript 0, original point will be 3 plus 1. So 2x 0 is 4. So the original point x coordinate value is 4 over 2, which is indeed 2. Let's calculate the y value also, which is minus half y0 plus 3 is 1, right? So rearrange, minus half y0 equals to 1 minus 3, which is minus 2. And now y0 equals to minus 2 times, well, multiply by minus 2. So we get that as 4, correct? So that is how you can find the original points. So now we can write down the answer that x0, y0, the original point is actually equal to 2, 4. You get the idea, right? So that is how we can actually find the original point. So you have to do reverse calculations in such questions. This is a very interesting question and it really brings in all the concepts which you have learned about transformation. I'm Anil Kumar and I hope you understand the concept. All the best for your test. Thank you. And subscribe to my videos, share such videos with your friends. All the best.